In this video, we're going to talk about integral tables. Integral tables can be a really useful tool to find integrals that are otherwise undoable by hand or very difficult to do. This is a table. I'll actually make a copy and give you a copy of this table to use for your homework, and then in the test I'll make a copy of this table, or I'll just kind of reference and give you a specific integral to use, like I'll do in an example. So no need to write any of this down or kind of memorize all this. But you can see how many different integrals there are kind of on here, and it even starts with just the very basic kind of power rule of integrals. There's natural log, here's integration by parts. It's got that inverse tangent in there, inverse sine. Here's the integrals of an exponential. So you can see there's tons and tons of different kinds of integrals in here. So let me give you a quick example kind of how this might work. If I can actually go back to moving this thing around. Let's pause it. Okay, sorry for that little technical difficulty. I figured this out. All right, so I just want to take a look at number 45 here. So we could do this, say, if we did like the integral of natural log of x squared plus, I don't know, say 4 dx. So if we wanted to figure out an integral like this, pretty easy to see that a would be 2. So we're going to use a equals 2 as a substitution into this formula. So what we would get for this integral is x times the natural log of x squared plus 2 squared would be 4, plus 2 times a, which happens also to be 2, and then inverse tangent of x over a, which is 2, minus 2x. So it's just a matter of substituting in a, figuring out what a would be and substituting it into the formula. Now I add a c in there since I didn't put bounds on that integral. And that's how to use an integral table. So let's do another example. Okay. So for this example, let's use number 11 from that table to find the integral from 0 to 3 of x squared divided by 16 plus x squared. All right, so we can just use the formula. We just have to figure out what a is. On that left-hand side here, a squared is 16, so a is going to be 4. Plug it into the formula. X minus a, which is 4, inverse tangent of x over a, which is 4, and we're going to evaluate this one from 0 to 3. So plug in 3. So 3 minus 4 times the inverse tangent of 3/4. And then we subtract when we plug in x, so we'll get a minus 0, and then minus negative. Inverse tangent of 0 is 0. So on this one, we're going to end up with 3 minus 4 times inverse tangent of 3/4. So you get the idea. It's pretty easy, just kind of making substitutions. All right, let's do another example. Okay, so now on this example, let's use this number 23 this time to find the integral of x over the square root of 5x minus 7. Okay, so on this one, I chose this formula because of these pluses and minuses in here. That can be a little bit confusing. So what this says is that if your integral is x plus a number, then what goes underneath that root will also be a plus, that's on top. But what goes in between this x and 2a is going to be a minus. So whatever's on the top of this goes on the top of each one of those signs, or if it was the bottom sign, then you would choose the bottom sign of each one of those. Okay, now the other thing that's a little bit more difficult about this is that in this formula there's a 1 out in front of x, and that's really important. We're going to need a 1 out in front of x and not a 5 in order to apply the formula. So we need to do some algebra first and kind of, what I like to say, like rearrange the furniture, rearrange the numbers, do some algebra to get a 1 in front of that x. All right, so I'm going to, underneath the root, factor out a 5, because that's going to leave me with that 1 in front of x. Now, what this does is it changes this 7. This 7 is going to need to be divided by 5 if I factor out a 5 out of both of those terms. And I always kind of double check my work. If I multiply 5 back in, I get 5x. And then if I multiply 5 back in there, the 5's cancel, and I do get a negative 7. Okay, so now the next thing that I'm going to do is bring that root 5. I'm going to separate the root 5 from the root x minus 7/5. And I can do this because it's multiplication. If there was addition there, I can't do this. But I can because there's multiplication. Separate root 5 from root x minus 7/5. So now what this does is it gives me this extra 1 over root 5 out in front of this whole integral, but now I've got my 1. Now I've got my 1 out in front of that x. Okay, so now I can start plugging into the formula. So the formula says that we're multiplying all of this by 1 over root 5, and I've got now multiplied by 2/3 times x. Now the sign on the first one is negative, so if it's a negative sign, it gets a positive in front of that 2a. So positive, so plus 2 times. Now a in this case, this was plus or minus a, so a is 7/5. So I'm going to put in 7/5 right there. And then that is all multiplied, another parentheses there, that is all multiplied by the square root of x. And then if the first one is negative here, if what's in the integral is negative, what will be here is negative. That's what's on the bottom. So I'm going to have a minus a, minus 7/5. Okay, so making this look a little neater, just kind of multiplying some things through. I'll have 2 over 3 root 5 times x plus 14/5 times the square root of x minus 7/5, and I better add c. Okay, so integral tables are pretty nice to use. It's a matter of figuring out what a would be or what you would need to substitute into the integral. Pay attention to the signs if there are kind of a switch of sign or not. And then sometimes there's a little bit of algebra to be done first. So keep in mind that an integral table could be used for part of an integral. You may be able to separate out an integral algebraically, and then the first part you could do by hand, and then the second part you might have to use an integral table. And I think that's about all I've got.